Hello, everybody. Today we will start a new topic inorganics concrete. Lesson 6, Part 2. Concrete as material in construction we will consider. We know that concrete as a building material is very widely used and unlikely to be replaced in the future. While concrete in one form or another has existed for several thousand years, modern concrete can be dated from 1824, when the patent for Portland cement was first taken out. Since that time, the type and nature of cements have varied both as a result of new material being employed and as the technology used in its manufacture has altered. Since the introduction of cement, concrete as a material has been used in many different ways. Typical examples include the frames of high-rise buildings as part of road-based in tunneling, bridges, dams, and ports. Indeed, most of the built environment contains some fraction formed using concrete. Manufacturing process includes grinding the material to a powder, a process which also uses energy. Consequently, there is much effort from the concrete industry to reduce the impacts it has on the environment. In addition to this, challenges to construct iconic and durable structures require concrete research to be continuously developing the material to meet these challenges. About topics and subtopics that we will consider on the topic concrete. So, concrete overview include the following subtopics: constituents, cement aggregates, water and admixtures, purpose and function of constituents, manufacture of cement, that includes components, types and properties, component materials required for cement making, manufacturing process, constituents of cement, types of cements, setting, hydration and hardening of cement or concrete, properties of aggregates, water and admixtures, that include properties of aggregates, properties of water, admixtures, need and type, chemical admixtures, mineral admixtures. Making and testing of concrete, mixing, placing, finishing and carrying of concrete, properties of hardened concrete, strength, compressive tensile and flexure, durability of concrete, creep and shrinkage. Very useful and important topic concept of reinforcing concrete with steel, properties and characteristics, types of concretes, mass concrete, reinforced concrete, pressed concrete, that include casting of slabs and grade, casting of a concrete wall, and casting of floor and roof framing system. Concrete, in its simplest form, is usually a mixture of cement powder, water, sand, and gravel. A range of cement powder exists on the market which impart different characteristics to the material. Concrete includes rock-like material and ingredients: Portland cement, coarse aggregates, fine aggregates, water, and admixture. It's optional. The water is necessary as when cement comes into contact with water, a chemical reaction commences which ultimately results in the past hardening. The sand and gravel, sometimes termed fine and coarse aggregates, form a matrix of strong particles of different sizes which, when glued together by the cement paste, form an extremely strong and durable engineering material. Sand and gravel can also vary in strength, shape, and texture. In the production of concrete, it's usual for all the materials to be added to a mixture consequently rather than one after the another. Also, in certain instances, the materials are added in a specific order. Modern concretes often include admixtures. These are small quantities of materials usually added into the mixing water which impart very specific properties to concrete. One example of this is the use of air androgen agent, which produce millions of very tiny bubbles equally dispersed through the concrete, which prevent the concrete from being damaged if it freezes. Here you can see a schematic illustration of concrete and various constituent parts. So, concrete include admixture, cement, fine aggregates, air, water, and coarse aggregates. Admixture, cement, fine aggregates, air, water, coarse aggregates. Concrete properties. The first property, this is very adaptable material. Elastic when mixed. Strong and durable material. Doesn't rust or rot. Doesn't need a coating. This is a concrete on this picture without any coating. Resists fire. It's very useful, important, and cost effective. Like we already know, concrete as a material has been used in many different ways. Typical examples include the frame of high-truss building for superstructures, as a part of road bars, in tunneling, bridges, dams, ports, and substructures, etc. Indeed, most of the built environment contains some fraction formed using concrete. Concrete as a building material is very widely used and unlikely to be replaced in the future. It does, however, require furnaces which use fossil fuels in its manufacture, and thus dispel carbonate into the atmosphere. In addition, the manufacturing process includes grinding the material to a powder, a process which also uses energy. Consequently, at present there is much effort from the concrete industry to reduce the impact it has on the environment. In addition to this, challenges to construct iconic and durable structures require concrete researchers to be continuously developing the material to meet these challenges. So, concrete materials. Concrete is a mixture of cement, fine aggregates, coarse aggregates, and water. The proportion of each material controls the strength and quality of the resultant concrete. And we know that modern concretes often have an admixture added. Concrete materials. Example: Portland cement. Cement is the staging agent of concrete, and the most of the cement used in construction industry is Portland cement. This is made from chalk or limestone and clay. Most modern cements, whether they are used in combination with other materials or not, contain some Portland cement. Portland cement is made by burning limestone and clay or similar materials in a kiln at temperature of up to about 1450 degrees Celsius. During the process, the material sinters and produces balls of clinker which are ground to form cement powder. Both the raw materials and the fineness of the material influences the properties of the cement. Portland cement is now known as Portland Cement CEM1, manufactured to conform to BS Eurocodes norm 197-1. This cement comes in two different strength classes and can be as a normal or repeat hardening. For example, CEM1 42.5 newtons represent the normal less strong type of the cement, whereas CEM 152.5 reinforced represents the stronger, rapid hardening version. To understand why a cement is rapid hardening or not, it's necessary first to understand the basic chemistry when water is added to cement powder. A reaction termed hydration occurs when water and cement powder are combined. The reaction is exothermic and so gives off heat. When cement particles are very finely ground, they have a range surface area compared to more coarse cement. So when water is added, more of the cement is available to react with the water. Rapid hardening cement is thus generally finer, but in addition contains slightly different proportion of some ingredient to ordinary Portland cement. Other type of cement: sulfate-resistant Portland cement, water resistant, Portland blast furnace cement, under low temperatures resist, and high alumina cement. The main properties: fire resistance. Also, there are white cement, which is combined with washed clean aggregates and produce concrete which is much whiter and used for architectural purposes. And another problem with normal or rapid hardening Portland cement is that certain sulfates found in groundwater or some pollutants react with the cement to degrade it. Sulfate-resistant cement is a Portland cement with the component which reacts with sulfates removed, so eliminating the problem. Component materials required for cement making: limestone, clay, chalk, lime, about 60%, silica, approximately 20%, alumina, approximately 10%, and others: iron oxide, magnesium oxide, sulfur trioxide, alkalis, carbon dioxide. Manufacturing process of cement: wet and dry methods. In both methods, raw materials are homogenized by casting, grinding, and blending. The manufacturer of Portland cement uses considerable quantities of energy, and one way of mitigating this is to combine waste materials which can be encouraged to contribute to the hydration reaction with cement. The waste materials do not require fossil fuel to burn them, this having been achieved in a previous process. They may thought still need to be ground to an acceptable fineness. The two most common waste materials to be combined with Portland cement are ground granulated, a blast furnace slag, which is a byproduct of iron smelting and pulverized fuel ash. Derived when pulverized coal is used in coal-powered power station. Ground-granulated blast furnace cement has slow hydraulic activity on its own and required being combined with Portland cement to be activated. Activation results from the lime and another alkaline which are produced from the hydration of a Portland cement. The ground granulated blast furnace slag may be ground into the Portland cement or blended with it at the time of manufacturing. In most practice uses 66% of a cement would be formed using ground granulated blast furnace slag. In this proportion, the blast furnace cement can be used for similar purposes to CEM1, but it gains strength more slowly. This means concrete formed using a blast furnace cement will generate heat from the hydration reaction more slowly and would therefore be suitable for very large concrete pours where the temperature differences from the center of the pour to the edge can be significant. Because concrete formed using blast furnace cement gains strength more slowly. It's not suitable where formwork needs to be struck at early ages. In addition, blast furnace cement are more resistant to sulfates than ordinary Portland cement. In less common cases, the proportion of ground granulated blast furnace slag can be increased up to 80% of the overall cement mass, which produces even slower heat generation during curing and better resistance to sulfate attack. So, about manufacturing process of cement. And first method is the weight process. Mix containing homogenized constituents and 30–40% of water is heated to 1510 degrees Celsius in a slightly inclined kiln. Oxide of silica, calcium and aluminium combine to form cement clinkers mixed with calcium, sulfate or gypsum to reduce the rate of setting and crushed into powder in ball mills before storing in silos or bags. Advantages of wet process that the wet process of cement production has the characteristics of simple operation, low dust and easy conveying, because the slurry has fluidity so that its homogeneity is good and the quality of clinker is improved. What's more, the energy consumption of raw material grinding in the wet process is reduced by nearly 30%. And disadvantages, this is the heat consumption of the wet process is too high. And usually between 5,234 to 6,490 per kilogram, and the consumption of ball mill vulnerable parts is also large. Compared with other processing methods, the clinker manufactured by the West process has a low temperature when it comes out of the kiln. So this method is not suitable to produce the clinker with a high silica rate and high aluminum oxygen rate. We will return to this slide later, and now about dry process. Dry process, what is this? The homogenized mix is fed into the kiln and burned in a dry state. Other steps are the same as for the wet process. Considerable savings in fuel consumption, but workplace is dustier. Advantages of dry process. As the dry process is to directly feed raw materials, powder into the rotary kiln to calcination. And the moisture content of raw material is about 1%, 2%. It saves the heat consumption needed for the moisture evaporation. Therefore, this method has the advantages of energy saving, high production efficiency and a stable output, which can meet the production needs of a large cement plants. At the same time, there is less sewage discharged in the dry process cement production. It's conducive to environmental protection. Nowadays, we call the production line with preheater and precalciner as a new dry process. Cement production line, which is the development direction of dry process cement manufacturing in the future. And disadvantages of dry process are the inhomogeneous composition of raw material, high power consumption, and the high dust content in the workshop.